Alright, so let's talk about the design hash map. So you want to design the hash map class without using a library. And then for the constructor, you just initialize the stuff. For the put, if there is a value in the map, you want to update. And then if not, then just insert, right? And then get, basically just return the value. And if not, if a key does not inside the map, return a -1. For the remove, just remove the key. And if there's no such key inside the map, just return nothing. But you still have to traverse. The idea for the hash map is using the what? The constant time, right? The constant time for the put, constant time for the get, constant time for the remove. And the algorithm behind it is actually what you create the size of the memory for the hash map, and then the size has to be what? The size has to be prime number, right? So you won't get the you won't have a corner case which you cannot get a probably get a duplicate number, or probably you cannot remove, right? Because when you are getting the value for a key, this is from 1 to n, right? And then you want to hash it. So we have a code. We have to create a function called hash, and this is going to be key. And for the algorithm, for the hash function, we will say k represent key. So key multiply a mode, and then you want to multiply the size of the what? Size of the map. And the mode and then size has to have to be a prime number. The algorithm behind the hash map is really interesting. If you still want to dig this out, then just go on Google, and then you'll get some just get some idea, right? And yeah, we need a hash function. And then let's talk about every single function for the put. So for the put, right, you want to what? You want to insert the value into the map, and if the key is already inside the map, you want to update, right? So we can use the idea to remove. So we want to remove the current key, right? We want to remove the current key, and then we insert the value into the map, right? So insert the value into the map. So you might be wondering that how do you insert, right? So if we know the hash function, which will return the int, and this is going to be the index, right? So you want to create a what? The list, is array of something. So array of ListNode, right? So I have a ListNode, array of ListNode, and I need to initialize the array to the size I mentioned. It has to be prime number. And yeah, so we will remove, and then we will insert the index. I'm going to call h for the hash key, and then I'm going to just update. I'm going to create a new list node to the list of array, and this is pretty much the put. So let me just start writing, and I just want to create a list node class, and I will have a key, I have a value, right? And I also have the node next. So the reason behind you need a node, the reason behind the next, this is because you are given the limit size of hash map, and since that you can insert a lot of stuff inside the first, just inside the same index, but in the same index you can traverse to the next value, right? Since we are multi size, and this might be and have the same remaining value, right? So you just traverse, and then if the current value if the current hash is inside this index, then you still have to traverse, right? So this is why we need the next, right? So in this one, we just we just call the constructor int key int val ListNode next, and then we initialize the list key equal to key, list val equal to val, and then list next equal to next. And then we need a constructor. Sorry, we need an array. ListNode array. I'm gonna call what? Data, right? And then data equal to what? New ListNode, and then size, right? So I'm gonna declare the size to the prime number, and for my prime number is what? 19997, and also I need a mode, and my mode is also a prime number. You can just go online to find a prime number, right? All right, so I'm gonna initialize my size, right? So for the put, I just have to remove the current key, but this is actually what? This is actually removing, right? I still need to insert, right? So for the insert, I need to create a hash for the key. So I'm gonna declare the public int hash for the key. So I want to return. So key multiply mode mod by size. This will be the hash value. But since this is way too big, I need to convert this to long, and also this is convert to long, but my return type is int, right? I need to convert to the int later on. So this is actually the hash value for the hash key, and then I just have to say, okay, for the current index, data, right? So this is data. So imagine I'm actually taking this spot, right? I'm taking this spot, and I'm adding the value. So I'm gonna I'm using the ListNode class. I'm gonna create an instance and add into the current spot. So so data at h, right, is actually equal to new ListNode, and then the key, the value, and also the what, and also data h, right? You want to point your next to your, just basically to yourself, and this is pretty much it, right? Like key value next. All right, let's talk about the get. For the get is actually much more straightforward. You want to traverse the current, the current data at edge index, and then since this is what, since there's a next, then you just keep traversing, and then until you hit the match when the key is actually equal to the key, then you return value. So I have an edge, I have to create a hash key, I have a list node, I'm gonna call it node, data at edge position, I'm traversing, and node is not equal to node, just keep traversing. So if the node.key is actually equal to the key, you mean it means that you find it, right? So you just return node.val, and otherwise you return -1, right? Alright, so let's talk about the remove. Remove is a little bit difficult for sure. So imagine that you are at, in this index, in this hash index, that you are actually connecting. So if you find it at the first position, right? If you find it at the first position, so node.key is actually equal to the key, right? Then you would definitely say, okay, this is no longer needed, but I still have a remaining, right? I want to put this as my head for the hash index. So I want to reassign my head. So reassign my head, and this is pretty much it, right? And otherwise you want to traverse. So imagine this is the imagine this is the key you want to remove, right? but we're still here, right? So when we want to remove this one, right, the current node, sorry, next color, the current node.next has to be pointed at here, right, if you want to remove this one. So we want to make sure the for loop is actually tricky. So for loop. So if we still have to traverse from the beginning. So since beginning is not the node you want to delete, then we want to just keep traversing. But traverse, you want to make sure the next val is not null, and then you jump to the next one. Right? So this is the condition for loop. Node.next is not null, and then you say node equal to node.next, right? And then when you want to compare, your, okay, so you are at a current position, right? You want to compare the node.next.val, sorry, node.next.key that's not equal to the key. So node.next.key, if this is equal to the key, right? So if this, I'm at this position, if the next key is actually equal to key, I want to make sure my current node.next point at here. So it's going to be node.next. Node.next is this arrow equal to what? Node.next.next, right? So node.next.next. Alright, so this is pretty much a solution. So let me start typing. So I still need a hash for key, ListNode for the node data at edge, and then I want to say, okay, if is my current value is actually equal to a key, right? Then I want to point my current value, data edge is equal to the next one, node.next, right? And also, if the node is already equal to null, then I don't need to worry about anything, right? I just have to return. So else, so this is more tricky, the one I talk about. You want to make sure the next is not null, and also null equal to node.next. So if the current value current next value is actually, current next key is actually equal to the key, then you want to what? Node.next is actually equal to node.next.next, and then you want to break out the while loop. Basically, this is all of one, right? So you want to break out the value as soon as possible. So once again, let me run it, see if I have any typo or not. Alright, no. So submit. Alright, so you definitely need to you definitely need to understand, I need to create a ListNode class to make sure I have a key value at next. And then, so the reason why we use next is we are at a limit size of HashMap, and then when we're using a mod, we can put the linked list at the edge index, right? At the edge index, the hash index, and then we just have to traverse. But when we put, we definitely need to remove the current key, right? So this is why I have a key. So if this is nothing inside if this key is not inside my map, basically I will return null, right? And then when you traverse, you definitely cannot find it. And then when we add, right, this has to be what? This has to be the current head, right? Am I right? Yes. So I'm pointing this. Yes. So I'm pointing this at my head, and you definitely need to traverse, right? So if you still worry what just happened, you can using this. Just give me 1 second. Alright, so if you still worry, what just happened on line 17, you can actually replace this to what? Create a list node of null equal to new list node, and I have a key, I have a value. I'm gonna point your current sorry, I'm gonna point the next value, the current node.next, right, equal to edge. So I'm going to say node.next is actually pointing at the data edge. So which is what? The beginning of the head, the beginning of the head, right? So node.next equal to data edge, and data edge is always the what? The head, right? And I'm gonna assign my head. I'm gonna assign my head equal to node, which is going to be a new head, right? So this is actually the other way to just to assign the new head of the edge index, and this is still doable. Alright, so this is pretty much a solution. So let's talk about the time and space. So okay, let's talk about this. For the put is what you remove, and if you find it, then you know you traverse the for loop. I mean, if you didn't find it, then you traverse the for loop, and then for the get, you still traverse. And then this is actually, you know, all of one, right? For the put, get, and remove are all of one, because this is the algorithm behind, right? And for the time and space, you know, this is pretty straightforward. For the constructor is all of them and represent the size, right? And then space, sorry, all of n for the space, right? And then the time is what? Constant. And then the hash function is what? Constant. And put is what? Constant. And this is get, and the other one is what? Remove. Alright, so this is a solution. So yeah, just make sure you know the algorithm behind it, and yeah, you will definitely get it. So if you still have a question, leave a comment below, subscribe if you want it, and I will see you next time. Bye.